Right. So one is concurrent. That was the word of the day that appeared new. Two's group was all the same stuff from yesterday, just sort of asked in a different way. So we have scalars versus vectors. For scalars, you should say magnitude only. For vectors, say magnitude and direction. Adding for scalars is algebraically. Adding for vectors is graphically. Example for scalar could be distance, could be speed, could be mass, could be other things. Example for vector could be displacement, could be velocity, could be force, could be acceleration, could be momentum, could be other things. 10 is with an arrow, either by drawing an arrow or just writing the word arrow. 11 is head to tail, with the head of one on the tail of the other, something like that. 12 is a resultant. For 13, you could either say that, and 14, it's the same answer twice, that the first one of the sentence is a scalar, or that the second one is a vector, or that the first ones don't have direction, or that the second ones do have direction, however you like to do that. 15 is independently. And then we'll pause the show for a minute. Let's see. For next time, we have a 19-point quiz, looks like. So it grew by 4. I don't think that's an oh my gosh moment. It grew by 4 points. I mean, come on now, people. When you read 5-7, there's 2 new points from the reading. And then 1 point of growth is because I misnumbered the paper. So there's only 1 other new point on this, apparently. And the rest of this just looks to stay the same. The new point has to do with what we're about to do here. Something that'll semi-confuse you for a little while. So some of you got mad early in the year when S was the variable, and as a variable it stood for distance or displacement. It was also a unit where S stood for seconds, and that made people kind of grouchy sometimes. Yesterday, every time I wrote a big capital N, that stood for north. In this setting, that is not what that's doing. Did anybody have an observation from last night reading what the N is about? It's a unit now for something. It's called a Newton. That is correct, named after Isaac Newton, a scientist. What does it measure? Force is correct. So the new question tomorrow, Tuesday, I mean tomorrow in school terms, but Tuesday in calendar terms. The new question is, the unit of force is the blank, and you would say Newton. But you now have to be a little careful whether that Newton is a force as a unit, or if the N is the direction on things, but just have to read the question and judge by context sometimes. But 5-7, that's our deal. Homework is 1 to 12. I'm not going to do one new thing on the board that I didn't do yesterday. If you understood yesterday, you're good. If you're a little dicey on yesterday, tune in and I'll do another little go around of the same stuff we were doing yesterday. I have a sort of like a medium one and then a harder one. You want the medium one or the harder one first?
Hard.
Hard one first, all right. So if I go 60 newtons and I head east, then I have another 40 newtons and I go in a direction 60 degrees north of east. That's a harder question because one of the directions is sort of like weird. You prefer me to stick north, south, east, west. That keeps your life simpler. This would be an example of what word from the quiz today, was it? Concurrent forces. They act on the same object at the same time. If we weren't living in the days of social distancing, we could demonstrate this by me walking out in the audience and picking on somebody. Gio's my closest boy. We try not to pick on the girls. But I could walk over there and I could start pushing Gio this way. And Amelia could start pushing Gio that way. If we're both pushing Gio, that is concurrent forces. And if I push this way and she pushes that way at the same time, would he go the direction exactly that I'm pushing? Would he go the direction exactly she's pushing? If we both pushed them, where would he end up going?
Toward cold.
Toward cold. Yeah, he'd head diagonal. Like we would work together, and neither of us would have the exact impact. We'd work together, and he'd end up going some random direction. That's what's going on with these. We have concurrent forces. They're acting in different directions, so stuff's going to go in some sort of diagonal direction. What was my tip on drawing? First thing to do?
Make a little,
Make a dot. Make like a starting point because we're always going to want to find the angle at the starting point. So if you don't mark your starting point, you may have some moments of indecision later when you're like, wait, what did I even want out of this? We want the angle that's here. Did I yesterday do the easier direction generally first or the crazier direction first? I'd do the easier direction first just to get off to a good start. So it's tempting to head up because you see this,
oh no.
but no. Which direction are we headed? East, which is to the right. So I'm going that way, and that's 60 newtons. That had nothing to do with north, it's 60 newtons of force. Newtons measure how hard we're pushing somebody. I probably wouldn't throw my 60 on yet until I have more of a triangle, because if I end up going this way, I'd probably prefer to write my 60 down here out of the way. But if I headed that way, I'd prefer probably to write my 60 up here out of the way. So I'm going to not write the 60 on yet until I see where my triangle goes. We're headed in a crazy direction, so at the head, what did I suggest yesterday you do just to help yourself go in the right direction on the weird ones?
Do like an imaginary.
Do like an imaginary sort of a map thing. Not too heavy, because it's not actually part of the picture, but it's just sort of a guideline to help us. Draw a little north, south, east, west imaginary thing. We're headed north and east, which would be in which direction?
Up to the right.
Up and to the right. And then we have a choice to make whether this is 60 or whether this is 60. Because I could have said something about east of north, right? So if I say north of east, it's one of them. But if I said east of north, it's the other one, and we just have to be careful. Which of these two is always the more important direction? The second one. Okay, so if east is mentioned second, I want the angle that's touching the east. There's a 60. Question about drawing the facts that I drew. That's illustrating the idea of we're solving this graphically. It takes a picture. I'm positioning the vectors so the head is touching the tail of the other one. Question there. Then I'm always going to draw in a thing that starts with R. What's that called? Resultant. The resultant always starts at your starting point. It's generally drawn as a dotted line. I don't know why. It just is. And the resultant starts at the original starting point, the original tail, and it'll go straight through to the head of where we finished up. And now I'm going to make triangle stuff out of this. So how long was this? 60. How long was this? 40. Inside the triangle, or on the triangle, how many items do we have? 2 right now. To do anything with triangles, you always need to know 3. So sometimes geometry gets us the thing that we need to get. How can geometry get us another item for the triangle? 180 minus 60, right here lives 120. There's a lot of ways you could come up with the 120. Okay, that's the simplest one. Another way you could have come up with 120 is that 60's friend to complete the quadrant would be another 30. Then this whole quadrant is another 90. 30 and 90 together, 120. You could get it that. I mean, there's other ways you could get it, but we've got to come up with a 120. Question about that. Okay, then calculus people celebrate because they have their programs, they've been using these for years, they're good to go. Trig people sort of celebrate if they have their calculator license because then they just run their program. People that aren't in trig yet are a little grouchy because you may not have these programs yet, and I'll put in another pitch for take this like 5-day break, go to the YouTube channel, find the video about which triangle is this called? This is an SAS triangle. Find the YouTube video that we made in trig class the one day, and we wrote ourselves an SAS triangle. Steal all the programming of that and get this input into your calculator so that we can run a program on this. So somebody grab your SAS, run it. It'll ask you for the sides, 60 and 40. It'll ask you for the angle, 120. It'll shoot you some answers back. The side, I'm hoping, is like around 87. Okay. So we'd be 87 newtons. But that's not the complete answer. Why not?
We need a direction.
We need a direction. This is an example of a
Force.
Magnitude. Vectors have magnitudes and direction. The direction is always the angle at the starting point. Your program will kick you back, if it runs right, something in the 20s and another one in the 30s. Is this angle in the 20s or is this angle in the 30s? It's in the 20s. How do you know?
Because it's a smaller size.
Because it's the smaller side. It's opposite the 40, which is smaller, so we want the angle that's smaller. And 100% of the time so far on the board, we've always had the smaller one. That's not the way life works. It's usually like 50-50. So don't get carried away, always grabbing the smaller one. But here, we want to grab that 24-ish. What of what? North of east. Our original direction we headed was east. So we are still moving something of east. And then if you look at the picture, we headed that way. We are to the north of east. Question about that? That's about as bad as it gets tonight. How someday could I create a problem, the book will create problems that are meaner than these? What made this one halfway mean?
They both have these.
Yeah, well,
They introduced Newtons.
yeah, that didn't really make it bad. Because if I had said this was, if I said this was 60 meters and this is 40 meters, the only change in our answer is that it's meters. So the existence of Newtons didn't hurt us. What made this a harder than average question?
Because we went like.
Why is that one going to be easier than this one?
Because there's no degrees. There's just one.
Three directions. And not one, and the other one.
Yeah, sort of.
That one's gonna be the right triangle.
Yeah, this is going to just be right triangles. Life's going to be easy if you just go north, south, east, west, right triangles. Not hard to draw right triangles. Okay. This was a halfway hard problem because I threw you a nutty direction. How could I give you a truly hard problem?
Two nutty directions.
Throw you two nutty directions. So if we have one thing going diagonal and the other thing going diagonal again, that's going to be a harder problem. That's someday in our future, but that's not today. What you're hoping for is just see north, south, east, west, and life is right triangles. But if they throw you one weird direction, we'll cope with that for now. This is as bad as it'll get for now. Question about that worst one?
We're not gonna have to worry about significant differences.
We'll go, on the test, we'll go 3. For the book homework, the book randomly rounds stuff wherever they get in the mood to round, so I'm not real worried about it till we take a test. But if this were a test question, I'd have 87 point something and 24 point something. But for now, for illustration purposes, that's not our main focus. Something about the first one? Okay, easier 1 second, but still the same skills apply. First thing I'm saying you ought to do, draw a dot for a starting point. And then draw either of these. It doesn't really matter which one you draw first, okay? You can add numbers in any order. You can add vectors in any order. If you have an easier and a harder direction, draw the easier one first. But if you have 2 easy ones, just pick one. So, where do you want to go?
20 right.
Go 20 to the right for the east. I won't commit to where I'm going to write the 20 until I see a triangle appear. From the head, well, I want to keep drawing.
100 down.
100 down. You don't have to draw this perfectly to scale, but you might want to, since 20 is significantly shorter than 100, you might want to draw your triangle in a way to represent the 20 thing, less than the 100 thing. But you don't have to worry about, is this 5 times as big? You don't have to worry about that. Then what do I do? Resultant goes from the tail original all the way to the head. And I have a triangle right now that has how many pieces labeled? 2. I need, how do I have 3?
Right angle.
Right angle. People that don't have programs, if you are comfortable with the trig stuff, Oscar and his apples, you could use Oscar and his apples to get that angle here if you want. You could use the Pythagorean theorem to get this side if you want. But your life in the long run will be simpler to, again, this is an SAS triangle because there's 2 sides and the included angle that's like where they connect each other is in there. 99% of our triangles are of this type, I think you're gonna do better just running the program. So either run a program or do the Pythagorean theorem or do whatever you wanna do. What's the side? It is 102. Units are always on here. Kilometers per hour. That's only half the answer because that's again called the magnitude. We also need the direction. You always want the angle at the start at the dot. Is it going to be the littler or bigger? Bigger for once. The 100 is across from the angle we desired, so we want the bigger of the two angles, which is
78.7?
yeah, 78.7. Which direction we started to draw first? East, so of east. And which way did we go from there? So. We'll do one twist before we go. What question about any of that before I do one small twist? This might not be in blue in the margin. In the margin might be east of south. And how would the angle change? 90 minus that. 90 minus that would be 11.3. If you were a person who at the starting point first drew south and then you went east, that's just as fine, but your direction's going to be like backward. So if I went back to adjust this, alternative answer here, it could have been east of north and not 24, 90 minus 24, which is
66.
Mario Lemieux. It's a hockey reference. It's a famous Pittsburgh hockey number. If you live in Pittsburgh, you should know Mario Lemieux. Sorry, I should. Anything? Questions? Okay, so 5-7 read, there was one new point, Newton's was the new point, misnumbering was a new point, we ended up with, or no, 2 new points, misnumbered one, Newton's is another one, total of 19, problems are 1 to 12. Happy Columbus Day. He wasn't the nicest guy to people in Native American times, but it got us 2 days left of school. Okay, so answers that are sort of new to the quizzes of this chapter, but not really new to our life at all. If you have vectors that are perpendicular, meaning right angles, how you can find the magnitude would be the Pythagorean theorem. For 2, how you'd figure out the direction, which is the angle, I would say tangent. If you said something about Oscar and his heap of apples, I understand what you're meaning, but we've been doing that like for weeks. But for 1, it's the Pythagorean theorem. For 2, it's stuff with tangent or O's over A's or some such thing. None of the math in this tonight will be any different than anything we've been doing the last couple days. So the only example problem I'm going to do in a minute is something that was in my notes from before break, and I accidentally skipped a question that might have caused you some homework issues. 3 to 11, we're looking for scalars versus vectors. Scalars have magnitude only, vectors have magnitude and direction. Scalars would be like distance or speed, vectors would be displacement or velocity, and there's others. Adding scalars is algebraically, adding vectors is graphically. 12 is arrows, 13 is head to tail, put the head of one on the tail of the other one, something like that. 14 is a resultant, 15 and 16 both. The first ones are scalars, no direction. Second ones are vectors, have direction. 17 is independently, 18 is concurrent, 19 is the Newton. And then why don't we do a quick math example, and then I'll do questions and scores, and that way we don't have to put the video back together. So this was a picture that I skipped last time. These are vectors acting on the same point at the same time. What is the word for that scenario? When vectors act at the same point at the same time? Concurrent. in the 1 to 12 homework at some point, they described to you a situation where vectors acted concurrently. And this would need to be your first drawing. If I have 70 newtons and 60 newtons acting concurrently at an angle of 40, I would have to have a point like this, draw two vectors, a 70 and a 60, doesn't matter who's where, and a 40 angle in between them. Does anybody have an observation on why is this not a good picture for adding vectors? Say it louder. They're not head to tail. How are they? Tail to tail. So when they in a paragraph talk to you about vectors acting concurrently, your first picture you'd have to make is a tail to tail picture, which is only semi-helpful. What we need for these vectors to do is be head to tail. So if I want to leave the 70, I'd have to kind of take the 60 and slide it up. Okay, what relationship does my new 60 up here, geometry relationship, what does this have to do with this? They are parallel lines. If you've been through geometry, these are parallel lines. They're being cut by a T word, yes? Trans? Transversal is correct. So we have parallel lines. They're cut by a transversal. We don't want the 40. We want to know an angle up there. It is 140. Does anybody remember what kind of angles those were called? No? Well, it's true. I? A? It's a 6-letter abbreviation.
Oh.
Yeah, we had corresponding angles, we had alternate interior angles, this is the other one.
Same side of transversal.
IA, SSTVs.
Yeah.
Interior angles on the same side of the transversal. That's our choice. Your other choice would have been leave the 60 where it is and take the 70 and kind of push it
Yeah.
to the right. But again, these two things would be parallel. Again, you'd have those IESSTVs. Again, you'd come up not with a 140, but with a 40. If that just completely confused you, here's the moral of the story. If you have a picture where they're drawn concurrently, do one starting point, they're both coming out of the same thing, write down the angle they give you, but realize that picture is useless. Make a new picture. Copy one of the rays in the same position it was in. Move the other one parallel so it's headed, the 70 is still headed the exact same direction. The 60 is just getting like lifted. And then how do we do the math transition? 180 minus. 180 minus what you had, make that new. If you have a calculator license, run your program. If you don't have a calculator license, get one too. If you're not even in trig yet, go to YouTube. Get the SAS program because it's going to speed your life up dramatically. And what I think the best way to do these triangles is program. SAS. Enter two sides, 60, boom, 70, boom. Enter angle, use 140, not 40. Boom. And it should shoot you back a 122 for this. We could cut that, and they would be newtons, because they were newtons. So we could cut that, and then we'll field questions.